Okay, at this point, you might want to pause and go ahead and complete the mole worksheet 1. Okay, that one is focusing just on doing these types of calculations with single atoms. Okay, the rest of our discussion, we're going to look at how do we do the same thing, but when we have molecules or compounds. Okay, and that will be related to mole worksheet 2. Okay, so here we have what is the mass of 0.25 moles of iron 3 oxide. Okay, so let's just lay this out first. All right, if we were going to lay this out, same way as we did before, moles of this, moles to grams is one step. Moles to grams. All right, and I use the values off the periodic table. So now we're going to go back to, remember in percent composition, how we found the total mass of the compound. We're going to do the same thing here. So I have, for the iron, I have 2 of those. Oxygen, I have 3. And 9, and iron is 55.85. So I get 1.7. That gives me 159.697, and this is the number, in addition to the atomic mass units, if I'm talking about one formula unit of this compound, this is also, if I have a mole of formula units, this would be the number of grams per mole. So that gives us 39.9 grams of the iron 3 oxide. Okay, so now we're going from number of molecules to grams. So we know we're going to have 2 steps, 52 grams of CO. I want to go grams to moles. Then I'm going to go moles to molecules. All right. Again, carbon and oxygen. 12.011 and 1 oxygen. And so I'm going to add those together. .001. That is my grams in 1 mole. And then 1 mole is 6.02 times 10 to the 23rd molecules. So 52 divided by 28.001 times 6.02, 10 to the 23rd. So that gives me 1.1 times 10 to the 24th molecules of carbon monoxide. Okay, and now let's see. The iron 2 oxide, we have 3.01 times, iron 3 oxide, 3.01 times 10 to the 23rd. Formula units. And I want to go from formula units to moles, and then moles to grams. Okay, so the iron, so our compound from before where we calculated that, the grams 159.66 grams in 1 mole. And 1 mole is 6.02 times 10 to the 23rd formula units. And so 3.01 to the 23rd divided by 6.02, 10 to the 23rd times 159.66. So we end up with 79.83 grams of the iron 3 oxide. Okay, now let's take kind of a little bit of a step further with this. All right, so say I have N2O5. I have 1.2 times 10 to the 25th N2O5 molecules. All right, and I want to know how many moles of oxygen atoms do I have? Well, the first thing, and this is always, when you're doing these problems, it's always a good first step. If you don't know what else to do, convert it to moles. So let's go from molecules of N2O5 to moles. All right, so 6.02 times 10 to the 23rd. 1.2 10 to the 25th divided by. And so that gives me 19.9 moles of N2O5. Okay, now it wants to know moles of just oxygen atoms. All right, so I want to go from moles of N2O5 to moles of oxygen atoms. Now, looking at the formula, N2O5, that tells me for every 1 mole of my whole thing, for every 1 mole of N2O5 molecules, based on that formula, I'm going to have 5 moles of oxygen atoms. Okay, so 19.9 times 5 gives me 99.5 moles of oxygen atoms. Okay? All right, let's look at another one kind of similar here. Here I have 17.5 grams of ammonium oxalate here, NH4 2C2O4. Now, I need a molar mass for that, so I'm going to just calculate this without writing it out, but you calculate it on your own and see if you get the same thing that I did. Or something close to that. Okay, I got 124.06 grams in 1 mole of my NH4 2C2O4. And now, where do I want to go from there? Well, I don't want moles of the NH4C2O4. I want hydrogen atoms. So not even moles of hydrogen atoms, but hydrogen atoms. So I'm going to calculate the moles of this first. All right, so that's 17.5 divided by 124.06. So that gives me 141 moles of the ammonium oxalate here. And then, all right, so now where do I go? Well, to get from moles of this to moles of the hydrogen, because that's what I'm interested in here. For every 1 mole of the whole thing, how many hydrogen moles do I have? Well, according to that formula, I have 8. Okay, so if I stopped there, I would have moles of hydrogen atom, but the question was asking for hydrogen atoms total. So I have one more step. 1 mole of hydrogen is going to be 6.02 times 10 to the 23rd atoms. Okay, so I have to convert that to atoms. So times 8 times 6.02, 10 to the 23rd, and I get 6.8 times 10 to the 23rd hydrogen atoms.